Assalamualaikum and good morning. My name is Fatin Nadia binti Muhammad Yassin, and today I will be presenting of a research titled Switchable Dumbbell-Shaped DGS for 5G millimeter wave in 26-28 GHz band. My talk this morning is divided into 5 main sections. First, research introduction. Second, theory and design. Third, experimental result. Fourth, conclusion. And lastly, list of all references. Introduction. Defected ground structure (DGS) can be found in circuit applications such as antenna, filter, switch, power divider, and power amplifier. The use of DGS in this circuit has its different purposes such as harmonics or frequency suppression, wideband performance, miniaturization, isolation, and load matching network. Therefore, in this paper, a defected ground structure DGS using dumbbell shape is proposed in the application of 5G millimeter wave in 26-28 GHz band K-band. It is switchable filter between bandstop and all-pass responses, the same design concept in 6. This design has the potential to be used in the RF switch design for wireless communications as reported in 7 and 8. Theory and design. Figure 1 is the equivalent circuit of switchable DGS, LNC, using a pin diode that can be switched between bandstop and all-pass responses. Referring to 9, all the bandstop responses of the switchable DGS during off-state of the pin diode, the S21 was derived as equation 1, where Z0 is a characteristic impedance of the input and output of the DGS. If the Z equals to 1, which is a normalized impedance, LNC will produce a bandstop response. Therefore, a standard frequency is equation 2. For all all-pass response, the DGS is short-circuited due to the on-state of the pin diode. Then, L will be 0 and let Z0 equals to 1, which is a normalized impedance. The S21 of equation 1 now becomes equation 3. So for equation 3, it shows that an ideal zero insertion loss can be achieved where all pass response is produced. Figure 2a is the dimension of the proposed DGS where A equals to 2, B equals to 1, D equals to 0.33, M equals to 1.13, and N equals to 3.13 and M. Capacitor is used as a DC block to create a small positive area of voltage supply to the anode of the pin diode. Figure 2b is the fabricated DGS that consists of 2 prototype ideal on and ideal off state of the pin diode. The DGS was fabricated using Roger RT Duroid 5880 with 0.254 mm thickness and relative dielectric constant of 2.2. Each prototype, the bottom view, consists of cascaded 2 DGS with the distance of 6 mm to provide a higher bandstop response. The top view is the microstrip line with the 50 ohm impedance in the 26-28 GHz band. Next is the experimental result. Figure 3 shows a simulated and measured result of the switchable DGS during the ideal off state of the pin diode. So the result produced a bandstop response with more than 30 dB of attenuation S21 in the 26-28 GHz band. Meanwhile, the return loss of S11 was very close to the 0 dB. Figure 4 shows the simulated and measured result of the switchable DGS during the ideal on state of the pin diode. The result produced an all-pass response with less than 3 dB of insertion loss S21 in the 26-28 GHz band. Meanwhile, the return loss S11 was higher than negative 10 dB across the band. The next step is to implement the actual pin diode with the biasing circuit for on and off state operation. As a conclusion, the proposed switchable dumbbell-shaped DGS for 5G millimeter wave in 26-28 GHz was designed and fabricated using Rogers RT Duroid 5880 material. A simple mathematical modeling was discussed for the bandstop and allpass responses. The measured result were tallied with the simulated result and were performed based on the ideal on and off states of the pin diode. Lastly, these are all references that are used in this research. That's all from me. Thank you.